Yes. So now let us discuss a problem. Given x and y, x and y are given with a m equals ax plus by and n equals cx plus dy. So with the AD minus BC equals plus or minus 1, then prove that M and N and X and Y have same GCD. GCD of Mn equals GCD of X. So for let D equals GCD of Mn and D dash equals GCD of XY. So D equals GCD of Mn means there exists some T and S falling set positive integers such that D equals Sm plus T. D equals Sm plus T. But what is M equals Ax plus By and N equals Cx plus Dy. So this D equals Sm means S into Ax plus By plus T into Cx plus Dy. So that means D equals, you can just associate this one. So it is D equals X into, what remains? X into, it is As plus Tc plus Y into, it is Sb plus Td. So it's of the form some Cx plus dy. It is of the form some Cx plus dy, or Cx plus dy means it's a linear combination of x and y. Since d dash is the GCD of x and y, then d dash can be rewrite as some lambda 1 x plus lambda 2 y as a linear combination of x and y. So from here you can immediately conclude that d divides d dash. Again, it is given that consider that it is AD minus BC equals plus or minus 1. AD minus BC equals plus or minus 1 means there is a linear transformation of the matrix ABCD that is invertible. Why? Because AD in this integers ABCD, because AD minus BC is plus or minus 1. Thus we can write x and y as a linear combination of this m and n. Linear combination of m and n. So that means, therefore, x equals dm minus bn and y equals minus cm plus a. Since AD minus BC is plus or minus 1, so the linear transformation of this matrix ABCD in the ABCD is invertible in this integers. So you can express this x and y as the linear combination of m and n, such as x equals dm minus bn and y equals minus cm plus a. But what is actually d dash? D dash is lambda 1 x plus lambda 2. Why? Because it is the GCD of x and y. So where lambda 1 and lambda 2 are integers, so this d dash can be rewrite as d dash equals lambda 1 x plus lambda 2 y means d dash equals lambda 1 into what is x? dm minus bn plus lambda 2 into minus Cm plus A. So d dash equals lambda 1 d into m minus b into n plus lambda 2 into minus Cm plus A. That is d dash equals m into lambda 1 into d minus lambda 2 into c plus n into a into n, not a suffix n, a into n. So it is n into lambda 2a minus lambda 1b. Whatever may be, lambda 1 d, lambda 2 c, lambda 1, lambda 2, a, b, c, d, etc. are integers. So this is nothing but the linear combination of m and n. So d dash is the linear combination of m and n. That means d dash divides d. So d divides d dash and d dash divides d. That combinedly gives d equals d dash. What is actually d? D is the GCD of m and n, and d dash is the GCD of x and y. So d equals d dash means they have same common divisor. That is the requirement. Okay. Now let us discuss another problem. Another one, such as let's say prove that n power 4 plus 1, n power 4 plus 4, number 1, n power 4 plus 4 is composite. Composite means not a prime. Is composite if n greater than 1. So this can be proved by using the idea a composite number can be expressed as some product of primes. So n power 4 plus 4 can be rewritten as n power 4 plus 4 equals it is n square plus 2n plus 2 into n square minus 2n plus 2. N power 4 plus 4 can be factorized as n square plus 2n plus 2 into n square minus 2n plus 2. Since n greater than 1, both of these factors, n square plus 2n plus 2, it is n square plus 2n plus 2 is greater than 1, as well as n square minus 2n plus 2 is also greater than 1. So n power 4 plus 4 is a product of two numbers that is greater than 1. So clearly n power 4 plus 4 is also a composite number. Let's imagine. Again, now consider another result or another problem. If a power n divides b power n, if a power n divides b power n, then a must divides b. Then a divides b. How? So listen. Let a equals a be the product of prime factors, power of prime factors. A equals I ranges from 1 to n or I greater than 0 pi power alpha I, and b equals product I greater than 0 some pi power beta I, pi power alpha I and some pi power beta be the unique prime factorization of this a and b. We already know that when a and b are composite numbers, then they have a unique prime factorization. Let a is product pi power alpha I and b is product pi power beta I are the unique prime factorization of this a and b. Now, when a power n divides b power n, we have to show that a divides b. If possible, a does not divides b. When a does not divides b, what happens here? When a does not divides b, there exists some alpha k greater than beta k for some k greater than 0. When a does not divides b, a and b have prime factorization like this. So if a does not divides b, then from here we can immediately conclude that there exists for some positive k, there exists alpha k greater than beta. Alpha k greater than beta k means so pi power alpha k should greater than pi power beta. Thus, pi power alpha k all power n should greater than pi power beta k all power n. Means pi power alpha k all power n greater than pi power alpha k all power beta n means, that means product pi power alpha k all power n is should greater than product pi power beta k all power n. What is this? This is a power n. That means a power n does not divide b power n. A power n greater than b power n. So a power n does not divide b power n. That means a contradiction to the fact that a power n greater than b power n. Thus, when if a does not divide b, then we have a contradiction. Therefore, when a power n divides b power n, a should divide b itself. Enough. Okay. So, now if n power n divides m power n, suppose if n power n divides m power n, do you say that n divides m? Is it possible? When n power divides n power n, is possible n divides m? Actually, this is a false statement. This can be proved by using an example. So, let n equals 8 and m equals 12. n equals 8 and m equals 12. So, what about 8 power 8? n power n form 8 power 8. So, this 8 power 8 is nothing but 8 means 2 cube. 2 cube all power 8 equals 2 power 24. 2 power 24. Again, this 2 power 24 into 3 power 12. 3 power 24 into 2 power 24 into 3 power 12. 2 power 24 can be rewrite as 2 power or 2 square all power 12 into 3 power 12. Means it is 4 into 3 all power 12. That equals 12 power 12. So, surely this 2 power 24, this 2 power 24 divides 2 power 24 into 3 power 12. Sure. We have 2 power 24 divides 2 power 24 into 3 power 2. This can be written as a product of this. But what is actually this one? This is nothing but 12 power 12. Okay. Then we conclude 2 power 12 divides, 2 power 8 divides 8 power 8. 8 power 8 divides 12 power 12. 2 power 24 means 8 power 8. So 8 power 8 divides 12 power 12. So when 8 power 8 divides 12 power 12, but you have 8 does not divide 12. When 8 power 8 divides 12 power 12, but 8 does not divide 12. So when n power n divides m power n, it need not be implies. It need not be implies n divides m. Agree? Okay. Now let us discuss another one. If n is prime, prove that 2 power n minus 1 is also prime. For any prime n, 2 power n minus 1 is prime. When n is 2, 2 power 2, 4 minus 1, 3 is prime. When n is 3, 2 cube 8 minus 1, 7 is prime. When n is 5, 2 power 5, 16, 2 power 5, 2 power 5, 32 minus 1, 31 is a prime. So, if you apply for different values of n, the result is immediate. But how can you prove this by in a general form? 2 power n if n is prime, prove that 2 power n minus 1 is also a prime. Now, if n equals AB, let n equals AB, A and B are greater than 1. Prove that 2 power n minus 1 is prime, then n is prime. Okay, if 2 power n minus 1 is prime, then n is prime. തിരിച്ചാണ് നമ്മൾ ആർഗ്യൂ ചെയ്യുന്നത്. നമുക്ക് പ്രൂവ് ചെയ്യേണ്ടതാണ് when 2 power n minus 1 is prime, then n is prime. ഇങ്ങനെയാണെങ്കിൽ തിരിച്ചാണ് ഇതിന്റെ ആർഗ്യുമെന്റ് എങ്കിൽ, suppose n is not a prime, n is the product of two numbers a and b, means a and b greater than 1. Then what is 2 power n minus 1? 2 power n minus 1 is 2 power ab minus 1. 2 power ab minus 1 means it is 2 power a minus 1 into 2 power a minus 1 into, it is 2 power a into b minus 1 plus etc. plus 2 power a plus 1. So 2 power n minus 1 can be expressed as the product of primes. That means 2 power n minus 1 is not prime. That's a contradiction to the condition 2 power n minus 1 is prime. So when n is prime, 2 power n minus 1 is always prime. So come to the reverse inversion. When 2 power n minus 1 is prime, then according to this argument, n is prime. So first we suppose that n is not a prime, then n is the product of some primes, n is a composite, n is AB, A and B are greater than 1. Then 2 power n minus 1 can be rewritten as 2 power AB minus 1. It is expressed in this form. That means 2 power n minus 1 is a product of primes, so product of some numbers. That means 2 power n minus 1 is not a prime. That's a contradiction to the choice of this 2 power n minus 1. Then similarly, Fibonacci series, Fibonacci sequence. So what is Fibonacci sequence? Fibonacci sequence is 1, 1, 2, 3, 5, 8, etc. It's a Fibonacci sequence. Fibonacci sequence is 1, 1, 2, 3, 5, 8. That sequence, it is given by, what about its nth term? It is an plus 1 equals an plus an minus 1. Agreed. Second term, except the first and two, third term is sum of the first and second. Fourth one is sum of the second and third. So n plus 1 third term is sum of the nth and n minus 1 third term. This is the general term of Fibonacci series. Then Fibonacci sequence defined by this recursion formula. Then clearly, what is GCD of A1 and A2? GCD of A1 and A2 equals 1. Okay. GCD of A1 is 1, A2 is 1, GCD of A1 and A2 is 1. So thus, then GCD of AN and AN plus 1 is also 1. They are relatively primes to each other. That is immediately proved by induction. So I just left it as an exercise for you. That is immediate by using induction hypothesis. Okay. Now come to another one. Let D equals GCD of 826 and 1890. Then use the Euclidean algorithm, compute this D and express D as a linear combination of this one. We know that if x and y have a GCD D, then this D can be expressed as a linear combination of x and y. Okay. So here find the GCD. First we find the GCD of 826 and 1890, and our assignment is express D as the linear combination of 826 and 1890. So the process is followed by Euclidean algorithm. That is, come to the largest one, 1890. 1890 can be expressed as it is if you divide 1890 by 826, 1890 by 826. It is 1890 equals 2 into 826 plus 238. 238. And now come to this 826 in terms of 238. What is 826 here? 826. If you divide 826 by 238, it is 3 into 238 plus 112. Now come to this 238 in terms of 112. 238 equals 2 into 112 plus 40. 2 into 112 plus 40. And what is 112? 112 equals 8 into 40. 890 in terms of 826. 826 in terms of 238. 238 in terms of 112, 112 in terms of its remainder 14, and 112 is expressed as 8 into 14. So 14 be the GCD of 826 and 1890. So D equals 14. And how to express the D? This 14 as a linear combination of 18, 90 and 826. So you can start 238 from here. What is 238? 238 equals 1890 minus 2 into 826. Therefore, 826 equals you can rearrange that one. Therefore, what is 826? 826 equals from here. 826 equals 3 into what is 238? This one. 1890 minus 2 into 826. That means, plus 112. From here. 826 equals 3 into 238 plus 112. That is 3 into 238 can be rearranged as 1890 minus 2 into 826. So from here 826 2 into there is a 3 into 2 minus 826 and there is an 826 minus 7 826. So this 112 can be from here 112 can be rewrite as bring this one. So it is minus 3 into 1890 then plus 7 into 826. This one. So from here again you can rearrange it as 112 equals this one, and what about 236? 238 equals, but 238 equals 2 into 112 plus 14. So by rearranging this one, 238 again come to this argument. 112 equals minus 3 into 1890 plus 7 into 826. But now here, what is 238? Come to this argument. 238 equals 2 into what is 112? This one. Minus 3 into 1890 plus 7 into 820. 7 into 826. 7 into 826. Then plus 40. So that means what is 14? 14 equals, then bring all these quantities to here. So it is 2 into minus 3. So minus 3 into minus 2 into minus 3 minus 6. So it is plus 6 into 1890 plus 7 into 2 14 minus 14 into 8 26. So after this one you have 14 equals. So finally 14 equals 7 into 1890 minus 16 into 826. So this is the linear combination of 14. So 14 is expressed as a linear combination of 826 and 1890. Agree? Okay. Then now let us discuss another one. If A and B are relatively prime, if A and B are relatively prime, there exists x comma y greater than 0 such that ax minus by equals 1. A and B are relatively prime, then there exists x and y are positive such that ax minus by equals 1. We already know that if A and B have GCD D, there exists x and y such that ax plus by equals d. Here A and B are relatively prime. Then there exists some positive integers, positive numbers x and y, such that ax minus by equals 1. How? So listen, when A and B are relatively prime, we know that there exists u and v fall in set, u and v are integers, u and v are fall in set such that au plus bv equals 1. au plus bv equals 1. So listen, au plus bv equals 1. This happens only when either this u and v are of opposite signs. A and b are, GCD of A and b is 1. Then there exists some integer u and v, maybe negative or positive, such that au plus bv equals 1. Since au plus bv equals 1, clearly u and v are of opposite signs. Opposite signs. If u positive, then surely v is negative. So u positive and v is negative. When u positive and v negative, put x equals u. Put x equals u and y equals minus v. X equals u and y equals minus v. So what I get? Au plus bv equals 1 becomes, it is ax minus by equals 1. Okay. Or if u negative and b positive, u and v are always in opposite signs. So if u negative and v positive, so what I get? Put x equals v, and yes, y equals minus v. So it's again ax minus by equals 1. Okay. So it is in terms of ax minus, put x equals u, y equals minus b, x minus by equals 1. If u positive and b negative, or if u negative and b positive, again there exists x and y positive such that ax minus by equals 1. Okay. So this is the proof. Now you can generalize this case. How some v minus a into b plus u plus b into a equals 1 is associated and so on. Then proceed. Now there is an important result. If a and b are relatively prime, then there is no positive x and y. Here it is a and b are relatively prime, then there is two positives x and y such that ax minus by is 1. Here, if a and b are relatively prime, then there is no positive x and y such that ab equals, no positive x and y such that ab equals ax plus b. There does not exist x and y positive such that ab equals ax plus b. How? Just suppose that it is possible. There exists some x and y are positive. There exists, if possible, there exists x and y are positive such that ab equals ax plus by. Then ab equals ax plus by. What is then? ab equals ax plus by. Clearly, a divides ab. Okay, ab equals ax plus by. A divides ab. A divides ab means a divides ax plus by. A divides ax plus b. So a divides ax plus by, but what is ab? A and b are relatively prime. A and b are relatively prime. So here a divides by. Okay. Listen, a divides ax plus by means we can rewrite as a divides ax and a divides by. That means a divides by. But since a and b are relatively prime, so surely a divides y. Okay. Again, b divides ab. B divides AB means also B divides yes, AX plus BY, why? Because AB is this one. So that means B divides AX and B divides BY. So that means B divides AX, but A and B are relatively prime, means B divides X. So A divides Y and B divides X. A divides Y means Y equals sum A into V, and B divides X means X equals sum B into U. Okay. Therefore, what is AB? Therefore, AB equals, it is possible, AX plus BY, that is A into X, BU plus BY, B into A. Okay. That means AB equals, it is AB into U plus V. That means U plus V equals 1. Okay, cancelling AB, then U plus V equals 1. So, U plus V equals 1, that's a contradiction. Why? To the choice of X and Y, there exist X and Y are positives. X and Y are positive means X and Y are positive. So, since U plus V equals 1, so that's a contradiction to the choice that X and Y are positive. So, X and Y are positive. This contradiction is due to our wrong assumption. Therefore, there does not exist X and Y such that AB equals AX plus B. Okay. This is the proof. AB equals AB into U plus V. Can cancelling this AB. So U plus V equals 1. U plus V equals 1. That since X and Y are positive, BU is positive, AB is positive, and but U plus V equals 1. That's a contradiction. Then the positive number greater than, yes, that is integers. And the positive integers, U and V are positive integers. So U plus V equals 1 never being possible. So that's a contradiction due to our wrong assumption. Hence there does not exist X and Y greater than 0 such that AB equals AX plus B. Agree? So this is our first chapter. Divisors, common divisor, and so on. So now let us discuss about the second chapter, arithmetic function and Dirichlet multiplications. That's in next class.